Good morning, students. We discussed the how to simplify the big function, Boolean function with the different method, but how we can identify and how it is useful to make any circuits. A logic circuits for digital system may be combinational or sequential. Remember that thing. Any combinational as or sequential, two type of the digital circuits are possible. A combinational circuit consists of a logic gates whose output at any time they are determined directly from the present combination of input without regarding to the previous inputs condition. Suppose right now the 10-second the output is something different according to the whatever the input condition, but as 15-second input is changed according to the output is changed. Output is only depends on the what is the presence value of input, not the previous value of input. It is known as a combinational circuit, or you can say that it is an open circuit. It is only depends on the current situation of circuit input combination. So a combinational circuit performs specific information processing operating operation fully specified logically by set of Boolean function. While the second type is known as a sequential circuit, which is a sequential element like a binary cell, which is used in addition with the logic gate, where the state of memory means memory, it is for to remember the previous values or previous input. So it is also depends on the previous input. This is the big difference which we be discuss later on in very depth. But before starting the combinational circuit, remember that digital circuit have a two part. One is the combinational logic, second one is the sequential logic. So here we discuss the combinational logic. A combinational circuit is consist of input variables. Here inside the arrow, these are the input variables. It maybe depends on the requirement of the problem statement. Logic gates, the black box, they are functional identified by the logic circuit means the logic gates are there, and output variables which generated m output variable according to the given the definition. So the logic gate accept the signal from this input, okay, different signal input, generate signal to the output. The process transforms binary information from the given input data to the required output data. Remember that thing, both input and output data are represented by binary signal 0 and 1. Here it is a binary signal, output is also a binary signals. They exist in two possible value, one representing the logic 1 and other logic 0. So this here the block diagram shown the description of the combinational circuit. An input variable come from the external sources and m output variable go to the external destination. In many applications, the source and or variables go to external are storage register located either the vicinity of the combinational circuit or in a remote external device. But as per the definition, the external register does not influence the behavior of combinational circuit, because if it does, the total processing become a sequential. So m input variable, there are 2 raised to n. Suppose here n input variables are there. So 2 raised to n possible combination of the binary input variables are possible, and for each possible input combination there is a exist one and only one possible output. Okay, it is not like is that the one input the number of output combination is possible. Every combination have a unique output in combinational circuit. Remember that thing. I'm sequential, it is a different case, while in combinational for unique input combination 2 raised to n combinations or 2 raised to n, every have a unique output combination. It is not depends on the situation. It is only depends on the whatever the current input variable condition. Each input variable to combined circuit may have one or two wire. When only one wire is available, it may represent the variable either in the normal form or an complement form. Suppose bubble shows that in uniformly, bubble shows that the complement form. Since a variable in a provided an inverter for literal not available into the input wire. On the other hand, the input variable may appear in two wires, supplying both the normal and complement form the input of the circuit. If so, it is unnecessarily to include the inverters for the input. The type of binary cell used mostly digital systems are in flip-flop circuits that have output for both normal and complement values stored into the binary value. We shall assume that each input variable appears in two wires supplying both normal and complement values simultaneously. We must also realize the inverter circuit can always supply a complement of the variable if only V wire available. Now, what are the main designing steps? How we can start design and make a combinational circuit for any given the problem. So remember that thing, the design of the combinational circuit start from the level of verbal outline of the problems. At the end of the logical circuit design diagram or a set of Boolean function from which the logic diagram can be easily obtained. The main steps are: first, a problem is stated. Suppose it is say that there is a input is a binary 3 bits and we have to create the output is equal to BCD. So first we identify the problem statement, then from the problem find out how many maximum input variables are available and require output variables is determined. Okay, like suppose a 3-bit binary, so obviously the input is 3-bit, but while the output is BCD, so it will become a 4-bit output. We have to decide it the output terminal side from the statement. Next is that uh, the input and output variables are assigned letter symbol because we have to find out the logical expression, and for that it is always in term of the alphanumeric codes like as A B C D or W X Y Z. Different input and output have a differ assigned letter symbol for each and every input as well as the output. Then the truth table defines the required relationship between the input and output is derived. For each and every possible combination of input, we have to identify what are the output is possible as per the given problem statement. Then using the simplified form like is in the form of K-map or using the Venn diagram or using the tabulation method, whatever the method is feasible, then the simplified the Boolean function for each and every output is obtained. Suppose I have a 4 output W, X, Y, Z, so I have to identify the logical expression for W, X, Y, and Z in terms of input A, B, C, D. And then whatever the expression, simplified expression, draw the logic diagram, which is the this circuit is satisfied the problem statement. Remember that thing, when truth table combination circuit consists of input and output, ones and zeros are obtained from the 2 raised to n binary conditions are available. So n input variable. It might be determined that the some combinations inputs are invalid. So we have to consider as a don't care condition. This combination don't care condition also useful to simplify the Boolean function. The output function specified the truth table give exact definition to the combinational circuit. It is important that the verbal specification of interpreted correctly into the truth table. Sometimes a designer must use his intuitions and experience to arrive at the correct interpretation. Word specifications are very seldom complete and exact. Any wrong interpretation which result in an incorrect truth table produce a combinational circuit will not be fulfill the stated requirements. The output Boolean function from the truth table are simplified by any available method such as a algebraic enumeration, a map method, or a tabulation method. There will be variety of simplified expression from which to be chosen. However, in any practical application, certain restrictions, limitations, and criteria will be served as a guide in the process choosing the particular algebraic expression. A practical design method would have to consider such constraint: first, minimum number of gates, minimum number of inputs to the gate, minimum propagation delay time signal through the circuit, minimum number of interconnections, limitations of driving capability of each gate. Since all these criteria cannot be satisfied simultaneously, and since the interpretation of each constraint is dictated by the particular application, and it is difficult to make the general statement as to what consists of acceptable simplification. In most cases, simplification begins with the satisfying the elementary objective, such as producing a simplified Boolean function in a standard form, and from that proceed to meet the other performance criteria. So today we discussed the design procedure about the combinational circuit. Is it making sense? Have a good day.